Okay, so when you hear late blight, what comes to mind? Probably a history lesson, right? The Irish potato famine, something from a long, long time ago. But here's the thing, the battle against its cause, Phytophthora infestans, is happening right now in fields all across the globe. And the rules of the game? They've completely changed. This is not your great-great-grandfather's blight. So let's crack open this new playbook and see what's going on. And that really is the central question, isn't it? Phytophthora infestans is a genetic shapeshifter. It's an absolute master of adaptation. It is constantly evolving to outsmart our fungicides and to get around any resistance we breed into our crops. I mean, it's an incredibly tough opponent. So to fight it, we can't just be reactive. We have to get ahead of it. This right here, this is the fundamental shift we're talking about. We are moving from a strategy of reaction to one of pure anticipation. You see, the old playbook, that was all based on guesswork. Spraying because it's June or because the weather feels a little damp. The new playbook is about knowing. It's driven by data, it's precise, and it's tailored to the specific threat in a specific field at a specific time. So let's start with that old playbook, just to see how far we've come. For decades, the main strategy was to spray fungicides on a fixed calendar schedule. A farmer would literally look at the date, check the weather, and spray. You were basically just treating a potential problem without any idea if the pathogen was even there. You just had to wait and see. Wait for those awful telltale spots to show up on the leaves. And here is exactly why that old approach is so incredibly risky. We now know that late blight's resistance to fungicides isn't always a permanent genetic thing. Thanks to a wild ability called phenotypic plasticity, the pathogen can quickly build up resistance when it's exposed to a chemical, and then kind of look like it lost it when you stop spraying. But that resistance, it's just lying dormant. The second you spray that fungicide again, bam, it can switch its defenses right back on. Spraying on a calendar is like fighting an enemy that can change its armor in the blink of an eye. You're always a step behind. So, how does the new playbook fight back? While the first huge revolutionary change is our ability to see the enemy before it even strikes. Think about it like this. The old way was like waiting for your house to be on fire. The new way is like having a smoke detector that goes off at the first tiny hint of trouble, giving you plenty of time to act before everything goes up in flames. We can actually find the pathogen before any symptoms are visible to the naked eye. So how do we do it? With technology that puts an entire diagnostic lab right into a farmer's hand. These new portable CRISPR-based diagnostics allow for testing right there in the field. Using something like a microneedle patch to get a sample, a farmer can pull out the pathogen's DNA, run it through a quick test, and get the results on their smartphone. This turns what used to be a week-long lab process into a real-time, in-the-moment decision-making tool. It's a game changer. But it gets even smarter than that. We've moved beyond just asking, is blight here? Now we're asking, okay, but which version of blight is here? For instance, when a super aggressive fungicide resistant strain called EU43A1 popped up in Ireland, authorities were able to identify it almost immediately. And this is so critical because knowing the enemy's specific identity tells you which of your weapons are going to work and which ones are totally useless. It lets you make a targeted, effective strike instead of just a blind scattergun spray. All right, so we can detect the enemy with incredible precision. What's next in the playbook? Upgrading the castle walls. We're talking about strengthening the potato itself, boosting the plant's own natural immune system. Now, when we talk about genetically modifying potatoes, there's a new, much more subtle technique that's really gaining steam. Traditional transgenesis often means adding a gene from a totally different species. But this new approach, called allele repair, uses CRISPR technology to find and fix broken or dormant resistance genes that are already in the potato's DNA. So it's less like adding a foreign part to your car engine and more like just tuning up the original one. And, as a result, it might just face a much smoother path through regulatory approvals. But here's the catch. There is no single universally resistant potato. It just doesn't exist. Why? Because the pathogens attack genes are different in different parts of the world. And that means a potato variety that's totally resistant in one place might be completely vulnerable somewhere else. So resistance has to be tailored to the local threat. It has to be context-specific. One size does not fit all. Okay, so we've got early detection and we've got stronger plants. The third piece of this new playbook is a much smarter offense. We are moving away from what's basically the chemical equivalent of carpet bombing and towards something way more precise. Think laser-guided strikes that only target the pathogen. And this is where something called RNA interference, or RNAi, comes into play. It's actually a natural biological process that we can harness for our own use. Imagine finding a critical page in the pathogen's instruction manual, like the one that tells it how to build its cell wall, and then just erasing it. The pathogen can no longer perform that essential function. It's an incredibly specific way to just turn the pathogen off without harming anything else around it.
Now, the biggest headache with RNAi has always been that the molecules are super fragile. They just break down really quickly in sunlight and rain. But recent breakthroughs in nanotechnology have solved this problem. Scientists can now load the RNAi into these tiny, protective nanoclay capsules. You spray these capsules on the plant, they stick, and they protect the RNAi, releasing it slowly over several weeks. This is literally how we're turning a fragile lab tool into a tough, field-ready weapon.
So let's bring this all together. We have in-field detection, we have smarter breeding, and we have precision treatments. Now, none of these is a magic bullet on its own. The real revolution here is how they all combine to create a strategy that's built on a higher density of information, finally moving us from simply reacting to disease to actively anticipating it. Just look at how our forecasting models have evolved. The old models, they only looked at one thing, the weather. If it was cool and damp, risk was high. That's it. But the new models are so much more sophisticated. Yeah, they still use weather data, but they add in real-time data from spore traps, which tells us if the pathogen spores are actually in the air, and they factor in how resistant the specific potato variety is. The result? A much, much sharper picture of the real risk. And what does all that extra data get you? How about around 92% accuracy in predicting when late blight will actually become an economic threat? That level of precision prevents tons of unnecessary sprays, which saves farmers money and, of course, reduces the amount of chemicals going into the environment. That's the power you get when you move from guessing to knowing. And that really brings us to the core idea of this whole shift. It's not about finding one perfect fungicide or one invincible potato. The real breakthrough is the shift in thinking, a move toward making decisions based on more and better information. We finally have the tools to see the whole complex picture. Ultimately, this new playbook runs on pure intelligence. To manage late blight today, you have to know the answers to these questions. Which specific strain is out there? Is it resistant to my usual fungicide? Is the threat even present right now? How strong are my own plant's defenses? And how are these huge trends, like climate change, altering the risk from one year to the next? You know, for the first time in history, we have the tools to manage this ancient disease with a kind of specificity that actually matches its own complexity. The technology for a smarter, more anticipatory defense, it exists right now. The bigger question is, are our strategies and maybe even our mindsets ready to adapt and actually use them? That is the real challenge ahead.